Sauce here. This is a video lesson on the fundamental theorem of calculus from area functions. From a previous lesson, we learned that the function notation a of x represents an integral from 0 to x, where x is the upper bound, the variable in this area function, of a function with respects to the variable that's used within the function. This x variable can be the same in the problem. The calculation won't be affected by that. Very often in this presentation, the function's variable and the variable that we represent the horizontal axis with is different than the variable that we are representing the upper bound, used to represent the upper bound. And this can also be presented as the antiderivative, capital F, of the integrand, lowercase f, as a function of the variable that's representing the upper bound. A little bit more specifically, the area then of any b, upper bound b, is the integral from 0 to b under the f function with respects to x, or the antiderivative evaluated at b. And the visual representation of this is to draw some curve f and have an upper bound b in this case, and this area then is the area of the shaded region from 0 to that upper bound. But of course, in presentations for area under the curve, we often have a lower bound as well, and we're interested in the area between a and b. Well, to get there, I'm going to do for a what I did for the upper bound b. I'm going to represent this region as an area function evaluated at a, where a is a different upper bound under the same function with respects to x, or the antiderivative evaluated at a. This integral here represents the larger area under the curve from 0 to b. And this integral here represents the smaller region, the area under the curve under f, from 0 to a. So what about the integral to calculate the area from a to b, or the integral from a to b under f with respects to x? We'll look at this visually. To get the region between a and b, I can approach it as finding the larger region from 0 to b and subtracting the smaller region from 0 to a, so from a to b remains. I have notation to calculate those two regions. If I take the larger one, the antiderivative evaluated at b, and subtract the smaller one, the antiderivative evaluated at a, then I will result in getting the area between a and b. What we have here is a presentation of a definite integral and then a way to evaluate that definite integral if we have known bounds and a function to work with that we can find the antiderivative of. This is the way to evaluate definite integrals. And because this mathematical truth is so useful, this has been called the fundamental theorem of calculus. And it has an abbreviation, FTC, but it's part 2. Part 1 was the establishment of the integral as an area function. so that we could use it for this extremely useful and very important "it's a big deal" expression.